Hi, Assalamualaikum and welcome back to my channel Physics from 5 KSSM. Today we continue 3.1 Current and Potential Difference Part 1. In this video, I will discuss three learning standards. The first one, explain electric field. Second, define strength of electric field E. The third one, explain behavior of charged particles in an electric field. How lightning occur? Observe how large amount of charges can be produced. I think you have observed the phenomenon of lightning. Can you explain how lightning occur? Watch this video. This is a large Van de Graaff generator that can generate charge at its dome. This is about a depth gauge experience when lightning strike. So you can observe how lightning occur. The person is in the cage. So you can see due to the imbalance of charges between the Van de Graaff generator and also the cage, you can see large amount of charge transferred to the cage. So this one will produce lightning. The person does not strike by lightning because the charges that pass through is already grounded. Okay, so you can observe how lightning occur. So if this person struck by this lightning, of course, this one will cause a fatal situation. In the lab, we have this structure of Van de Graaff generator. The size is a bit smaller. Maybe some of you have tried this in a science lower form. So we'll discuss more about this Van de Graaff generator. Van de Graaff generator. So you watch this video and observe what happens to the girl when she touched the dome of the Van de Graaff generator. As we know, the dome of Van de Graaff generator accumulate charge. So look at her hair. Her hair stands up, all stands up. So how to explain this situation? When Van de Graaff generator starts charging, it transfers charge to the person who is touching it. Since the person's hair follicles are getting charged to the same potential, meaning same charge, they try to repel each other. This is why the hair actually stands up. Okay, for example, if the dome is positively charged, so the hair, all the follicles of the hair has a same light charge, positive charge, so produce a repel. Okay, so you can see all the hair stands up. Okay, you have discussed about electrostatic before. For example, by rubbing a comb and then you bring the comb near to the tiny pieces of paper, so you can observe that tiny pieces of paper are attracted to charged plastic comb. Or you rub a balloon, so it becomes charged balloon. When you bring it clear your hair, you can see hair is attracted to charged balloon. Or the comb, you rub the comb with cloth and then you bring near to the stream of water, so you can see the stream of tap water is bent when a charged comb is brought near it. So all these situations, showing that the existence of electric fields between the comb and the paper, between the balloon and the hair, between the comb and the stream of water. Okay. So can you list some other examples of existence of electric fields? So we discuss more on this topic of electric field. What is electric field? An electric field is the region around a charged particle where any electric charge in the region will experience an electric force. So this is a 3D image for the electric field lines. Let's say we have a charged body, positively charged. the region close to the charged body is a region that we call it electric field. Once you bring a charge unit, let's say a positive charge unit, near to the charged body, the charge unit or the positive charge unit will be repelled. As we know, like charges repel. Or a negative charge unit bring near to the charged body. Okay, the charge unit will be attracted to the charged body because unlike charges attract. So from here we can see the charge unit experiences electric force. Why the charge unit experiences electric force? Because the charge unit is placed in the region that we call electric field. Normally, the region of electric field is the region which is closer to the charged body. It becomes weaker if the distance is further away. So between these two plates, for example, this is a positive charge, this is negative charge. There will be electric field between, okay, these two plates. Okay, so it exerts force on a charge placed in the field. Any charge unit placed here will experience electric force. So we call it electric field. You can refer to your textbook, activity 3.1. In this activity, we want to show the existence of electric field and also pattern of electric fields. Apparatus required, electric field kit. This is electric field kit. Extra high tension power supply. Okay, 2000 volt up to 6000 volt. Materials required, olive oil and semolina powder. Instruction setup apparatus as shown here. Pour olive oil into petri dish. Sprinkle semolina powder on the surface of olive oil. Switch on the EHT power supply and observe the movement of semolina powder. Record your observation in table 3.1. Repeat step 3 to 6 with pair of electrodes of different shape as shown in table 3.1. So you can see this is a petri dish. Just pour some olive oil, so you can use a cooking oil or castor oil. Okay, and then we have two electrodes. The electrodes can be a metal plate or a sharp end metal. And then they are connected to terminal, positive and negative. Okay, so we want to observe what happens to the semolina powder once EHT power supply is switched on. When semolina powder is placed in electric field, it experiences electric force. The pattern formed by the semolina powder shows the pattern of electric field. So it will align itself, the semolina powder, to form pattern. Okay, you watch this video to observe how activity is carried out. First, attach electrodes to the apparatus and screw in tightly. The two electrodes that we use here is two parallel plates. Okay, we can pour in castor oil. Aim for 0.5 cm depth. Sprinkle semolina seeds on top or semolina powder. Other materials that can be used to replace semolina powder is talcum powder. Okay, increase the voltage to 4000 volt. Watch the semolina seed align themselves with electric field. So once you switch on, there will be electric field between positive and negative electrodes. So the semolina powder that is in the electric field will experience electric force. Thus, it will align themselves to form pattern for electric field. So you can see it's just like a parallel lines between the two parallel plates. Okay. The electric field lines for the electric field, the direction is always from positive to negative, meaning outwards from positive charge, inwards for negative charge. Let's look at some example. Let's say the electrodes here, we use two sharp end metal. One connect to positive terminal, one connect to negative terminal. So we have unlike charges here. Unlike charges attract. So you can draw the lines for electric field lines. The line joining from positive to negative. Out from positive into negative. At the end here, this is positive, so outwards. Here is negative, so inwards. So this is the pattern for two unit of charge, unlike charges. Let's say we have one sharp end and one plate. Positive, negative. So how to draw the pattern? We represent electric field lines with a line with arrow. You can draw it full line. Okay. Direction positive to negative. Okay. This is parallel plates. In between parallel lines and quite uniform. At end here, curve a bit. So we can say this is the last unit of charge. Okay, so it becomes a bit curved. So this is example of electric field pattern that we can observe when carried out this activity. Okay, let's discuss some question involving this activity. Why is EHT power supply used in this activity? To produce stronger electric field so that large force produced that can move the semolina seeds or semolina powder. What happens to parallel plates electrodes when EHT power supply is switched on? Okay, the two metal electrode will have different potential. One positive, another one is negative. Okay, thus an electric field exists between two electrodes. Why does the sprinkle semolina powder form a certain pattern when EHT power supply is switched on? Because semolina powder experiences electrical force when it is placed between the two electrodes. So this observation indicates the existence of an electric field. What is the function of olive oil in this activity? Olive oil is not a conductor. Okay, so meaning the electric field that act between the two electrodes just act on the semolina powder. Okay, let's look at the property of electric field. This is a bubble map. The first one, outwards from positive charge. We talk about direction of electric field lines. Inwards for negative charge. Electric field lines never cross each other. Using lines with arrows. Electric field line is stronger, thus the lines closer and denser. Meaning if you want to draw a stronger electric field, so you need to draw more number of lines and the lines are closer. The concept of like charges repel is used and also unlike charges attract. So this is how the properties of electric field we use to draw electric field pattern. So when we talk about electric field strength, E, what is the meaning of electric field strength? At a given point in an electric field is defined as electric force acting on a unit charge placed at the point. So we have this formula, E equals F divided by Q. Meaning electric force per unit charge. E is electric field strength, F is electric force, Q is quantity of charge. Thus, the SI unit from this formula is Newton divided by Coulomb or Newton Coulomb to the power -1. So this formula represents electric field strength at a given point in electric field. Okay, let's look at between two parallel plates. We have observed earlier electric field lines between the two parallel plates are uniform at the center part. But at the end part here is a bit curved. So that one becomes non-uniform. Now we just want to look at the uniform part of electric field. A uniform electric field between two oppositely charged parallel plates. Let's say the separation distance between the two plates is D and the voltage of EHT supply is V. The lines that we draw with arrow here represent electric field lines. We draw it same separation distance between the lines, showing that uniform electric field. So if we have this situation, then we can have one more formula for electric field strength E for two parallel plates is E equals to V divided by D. V is the potential difference between parallel plates, and small d here, distance between two parallel plates. And then the SI unit for E here in this formula is volt per meter. Volt divided by meter. So we have volt meter to the power -1. So until now we have discussed two formula. The first formula E equals to F divided by Q is for a unit of charge, a point in an electric field. When we discuss about uniform field for two parallel plates, we can have the second formula. E equals V divided by D. So make sure you can differentiate between these two formulas. Okay, let's observe activity 3.2. The aim of this activity is to show the effects of electric field on charged object. Apparatus required: EHT power supply, metal plates, retort stand, polystyrene ball wrapped with aluminum foil, nylon string, and candle. So when we on the EHT power supply, displace the polystyrene ball to touch one of the plate. Record observation. Okay, when the ball touch one of the plate, and then you can observe what happens to the ball. Record your observation, and then you can switch off the EHT, replace the ball with candle flame or lighted candle. Observe also what happens to the candle flame. So from the observation, what we can say about the movement of the ping pong ball and also what happens to the flame of lighted candle. Okay, let's look at this one. This activity for ping pong ball. Watch this video to observe what happens to ping pong ball. So you can see the first time the ball touch one of the plate, the ball start to oscillate between the two plates. The oscillation will continue until you off the EHT power supply. So the movement or oscillation of the ping pong ball showing that there is electric field between the two plates. Now we off the EHT power supply, so you can see the ping pong ball return to original position and become at rest. Okay, let's discuss some questions regarding this activity. First one, why must polystyrene ball be wrapped in aluminum foil? If we just use polystyrene ball is an insulator. It cannot be charged. So once we wrap with aluminum foil, aluminum is conductor, thus it can be charged and discharged. Okay. What is the function of nylon string? Nylon is used to hang the ping pong ball. Nylon is an insulator. Thus, the charge from the aluminum coated or aluminum foil does not transfer to other object. What will happen to the movement of polystyrene if distance between metal plates increases? To answer this part, you must remember the electric field strength E between two plates. we have the formula E equals to V divided by T, the voltage of EHD divided by the distance between two plates. So from here, if we increase the distance between metal plates, meaning strength of electric field becomes smaller. So the polystyrene ball oscillates slower. Okay, the rate of oscillation of ping pong ball can be increased by, actually this one is based on the formula E equals to V divided by T. Increasing the voltage of EHD power supply or decrease distance between two plates X and Y. So we can increase the rate of oscillation or increase the strength of electric field between two plates. How to explain the situation involving the ping pong ball just now? Initially, the ping pong ball wrapped with aluminum foil is neutral. So it just stay at the center here at rest. What you do, when the power supply is switched on, the metal coated polystyrene ball, which is between the two charged metal plates, does not move. The polystyrene ball is neutral. Then, when the polystyrene ball displays to negatively charged metal plates, positive charge, this is they have a positive and negative, the positive charge on the ball will be discharged or neutralized by the negative charge on the negative plate. So what happens to the ball? The polystyrene ball becomes negatively charged. The ball is negatively charged, the plate also negative. It will produce repel force. So the repulsive force will pushes the ball away. When pushed away, the negatively charged polystyrene ball will be attracted to positive plate. Means it will touch the positive plate. What happens next? When polystyrene ball is displaced to positively charged metal plates, negative charge, just now, negative charge of the ball will be discharged or neutralized. Then next what happens? The ball will be charged with positive charge because it's touching the positive plate. Once it becomes positively charged, it will produce repel force. Okay, so the ball again repel away from the positive plates. The positive charge ball will be attracted to negative plates, and the same process repeated until we can see the ball oscillate between these two plates and stop when you off the EHD power supply. Okay, let's say now we replace the ball with candle flame or lighted candle. You observe what happens to the flame of the candle. Watch this video. When the EHD power supply is on, you look at the candle flame. So you can see the candle flame will flick and large amount of or the large portion of the flame is attracted to negative plate. Okay, this is what happens. Okay, so larger portion of the flame attracted to negative plate, smaller portion to positive plate. How to explain this situation? The hot flame of the candle ionizes the air molecule in its surrounding into positive and negative ions. So there are positive and negative ions. The portion that is attracted to negative plate Y is very much larger than portion attracted to positive plate X. Why? The bigger portion of flame is attracted towards negative plate as the mass of positive ion is larger than that of the negative ions. Okay, that means the positive charge will take larger portion of the flame as compared to negative ions. That's the reason why the portion of the flame is larger attracted to negative compared to positive plate. Okay, that's all for my first video. I will continue next part 3.1 current and potential difference part 2. Okay, where I will discuss on current and potential difference and also formative practice 3.1. So that's all for today. Thank you for watching. Bye.